Hello, good morning, everyone. Today, I'm excited to share one of our capstone project, which is Fed-GPT, translating Fed speak. Have you ever read any Federal Reserve statement or felt like it was written in any other language? Okay, here we come into the picture. We transcribe this complex written Fed speeches into much more transformable language processing unit. So let's dive in. And before we dive in, so let me introduce you to our team, which is I've had the privilege. So myself, Kushal Gada. I'm a Lehigh MFE, class of 2025, and we have our amazing sponsor, which is Mikhail Somonov. He's the CEO of Two Centuries Investment, and my other teammate is uh, Nick, and the other one is Tyler. So let me start with you. Let me start with some context. Short-term interest rates. So this chart shows us about 3 months treasury bills over a key rate short period of time, closely influenced by the Fed policy. Notice the dramatic fluctuations, especially with the recent decades. The challenges were faced connecting these market movements to actual languages, which is used by the federal communication. And this is where our project comes in. And yeah, so uh, at the heart of our engine, we have the sentiment analysis, which we are primarily harnessing ChatGPT's OpenAI. So we collect the Federal Reserve data, which is deriving from past 1935, and we have divided it into a batch processing using ChatGPT's OpenAI API. And we extract the sentiment scores across multiple dimensions, including short and long-term sentiments, surprise factors, credit conditions, consumer demands, economic growth, employment, inflation, and Fed actions. We call this the Ray Dalio phases, which is named after the most infamous investor, and it's one of his cycles that we are following right now. Uh, so the prompting techniques that went into the engine was to achieve these accurate results. We implemented several advanced techniques, especially in prompting strategy. We use chain of thoughts reasoning with self-consistency decoding to ensure the logical coherence. And we incorporated RAG, retrieval augmented generation, in order to pull relevant contextual information, which leveraged in context learning to adapt to specific patterns in the Fed language and use the complexity based prompting to handle with the sophisticated economic concepts. And we basically training the model to think like an economist. Just to give it a bunch of text and make sure it thinks like an economist. Right. So the whole process overview is here. Uh, so it follows 4 key steps. First one being we develop our prompts collaboratively with our sponsors, incorporating scoring mechanisms from a scale of 1 to 5, which measures economic factors, sentiments. This formed the foundation of our framework for the analysis. And here's how the pipeline works. First, we begin with the web scraping, the Fed Reserve website, going all the way back to 1936, focusing primarily on the statements, reports of the policy action. We then use OpenAI ChatGPT and GPT 4.0 mini model to analyze these documents, which are carefully prompted to extract consistent sentiment scores. The results are then processed to calculate the probability weighted average and finally reported to a structured format. The prompting structure, the slide shows the technical structure of our prompt. It might look complex, but essentially we create a systematic way of uh, of communicating across different tickets. The prompt is usually the hero of the projects, which is getting in the right crucial phase of the results. And this is the system configuration. For the technical folks in the audience, here's a peek under the hood at how we configured the system for our prompts. We instructed the model to act as an economist and an investment analyst, and provided detailed descriptions of the Ray Dalio economic cycle phases to give the model proper context for the analysis, right? And so, yes. Uh, User role configuration here. On the user slide, we structured our prompts to follow a consistent JSON schema, ensuring that the model output would be easy to process programmatically. And this approach allowed us to batch process thousands of Fed statements efficiently. And this is the correlation analysis. Our initial analysis revealed the fascinating correlation among the sentiment metrics. Fed actions were the most commonly strongly correlated with inflation and employment. There was no surprise, but given the Fed's dual mandate, interestingly, we found that the credit conditions showed a stronger correlation with the Fed action than expected, suggesting an unspoken third pillar of the Fed policy focus. So, yes, short-term debt cycle. This illustrates how Ray Dalio's short-term debt cycle model would be incorporated in our analysis. The economy moves through six distinct phases. For the early cycle, through mid and the late cycle into tightening recessions and eventually recovery. Our model learned it quickly with which phase the economy was based on Fed language. And these slides detail the detail the phases definition that we have used or programmed into the system. Each phase has a distinct characteristics related to growth, inflation, credit conditions, market behavior, and understanding these phases helps the investors to anticipate economic transitions, potentially to profit from them. My bad. Yeah, phase and return correlation. And here's where it is really interesting. This table shows the correlation between economic phases and market returns. Notice how different phases consistently produce different return phases, different return patterns. Phase six, which represent the late recession period when the Fed begins easing, has historically produced some of the strong forward returns. And this chart here, the extracted phase data, which is derived from our extraction, shows that what phases our values are extracted from for Fed statements over the time. The y-axis represents the number of phases from 1 to 6, and you can clearly see the cyclical nature of the economy based purely on the language used in the Fed communication. This is the website overview. We are not just creating a research, we are trying to make it more accessible. We've developed a website that will be hosted in the Fed-GPT analysis, complete with blog posts explaining our findings and automated data updates after each Fed meetings. This site will be hosted on Lehigh domain, similar to P100 index. And these are the technical details and the correlation analysis. The next several slides explore the technical details of our sentiment extraction, correlation analysis. We tested various statistical approaches, including Spearman correlation, and found statistical significance between our extracted sentiments. Actually, market movements after refinement, we improved our correlation coefficient substantially. And the next steps. So looking ahead, we have three main directions for continued development. First, we'll research additional relationships on the sentiment matrix to find even strong predictive signals. Second, we'll experiment with more advanced predictive models to generate actionable investment insights. Finally, we'll backtest trading strategy based on the sentiment signals to validate the real world applicability. On our promising applications, these are the TV3 minutes directions. We can exhibit on a which tells us that our model first determines if the rate will change or will occur, and the direction and predicts the direction. We achieved about 59% overall accuracy with the particularly strong performance during rate hike cycle, where the model accuracy predicted about 81% of rate of increase. Here are the features based on feature correlations based on, we did some feature engineering and the feature correlation based on the TB3MS as a predicting variable, as a dependent variable with different lags and different quartile features. And So this is the different models that are used in the action, which where the two-step model with the best performer showed about 59.115% of accuracy in predicting with splitting the model into train test case and predicting the TV3MS as a dependent variable. Uh, the two-step classification approach, basically splitting the data based on increased change and no change, was the best medium of so the best way of determination, which showed about 50-60% of accuracy and the strongest performance during the rate hiking cycles. The most accurate at the prediction rate were about 81% accurate, so which showed a stronger correlation whenever there is a rate hike. The model performance across different economic cycles. The performance varies significantly across different economic movements. So pre-COVID, the accuracy was about 35%, but of COVID crisis, we had about 50% accuracy. But we have the highest accuracy in the phase, especially whenever there is a rate hike. So our model is the best predictor of a rate hike rather than in a generic condition. So we can use it or split it based on a specific economic period or an economic event, and it has given us a highest accuracy rate. Uh, and this is the phase prediction, like an inverse prediction based on the treasury rates. And here the TB3MS volatility has an highest contribution towards a feature. The basic here the other features we have included other features that were included were rate change of measure, the directional indicators, acceleration metrics, which is the change of change, moving averages, about 3, 6, or 12 months, deviation from the moving averages, volatility indicators, and cumulative change over different windows. And apart from that, the seasonal features like months and the quarters. Here's a graph that is telling you the difference between the predicted and the actual phase. The method or the implementation, the methodology used here was LOCV, the least object oriented, and for the TB3MS. For phase detection and class balancing techniques for addressing imbalanced data. The validation approaches used were chronological validation for data leakage, preventing data leakage, and it showed statistical significance, which when it was tested across multiple economic cycles. The further enhancement to the model will be incorporating additional sentiment metrics, especially inflation, employment, develop multi-class classification for magnitude of moves, and explore deeper learning approaches for sequence modeling. And it would all be integrated with the website. Thank you for your attention. Fed-GPT represents a new approach for quantifying qualitative central bank communications, potentially giving investors a systematic edge in anticipating the monetary policy shifts. So we are excited about the possibility that this academic project and research would practically open up and have a real-time implication on investment applications. I would be happy to answer any of the questions you have. Thank you.